Okay, I hope you can see the slides. Thank you very much for the introduction. Yeah, so in this presentation, I want to show some recent discoveries from the IODP expedition that happened in 2022 and 2023. And this is about a kind of surprising eruption within Santorini caldera. So just as a little bit of a background, 3,500 years ago, the Minoan civilization populated large parts of the Aegean Sea. They were very advanced in terms of their architecture and art. These are some frescoes from the Minoans. They were a seafarer civilization, so they relied heavily on trade. And then, yeah, approximately 3,500 years ago, something happened. So we know that at that time, Santorini looked something like this. It was a pre-existing caldera, water-filled with a central edifice, and basically the perfect harbor for the Minoans to settle. But then, as the Minoan eruption occurred, huge amounts of ash and gas were released, leading to a major eruption that also collapsed the caldera. And then subsequently, 100 years later, traces of the Minoan civilization vanished. And now the idea is that this big eruption, which caused tsunamis and huge damages, was probably contributing to the demise of a civilization. And Santorini, if we stack up here 10 largest eruptions in the Holocene, ranks among the top 10. A recent study by Jens showed it's approximately at number 7, so 34.5 cubic kilometers of dense rock equivalent were erupted. And we are interested, of course, what are the implications for Santorini nowadays? With most of these large-scale eruptions that produce calderas, we talk about caldera cycles, and this is very much the case for Santorini. So after a big eruption, we think that the plumbing system is rejuvenating, recharging, which means we have frequent eruptions of smaller scale. And then as time progresses, the system matures, the eruptions become less frequent, but bigger, until the system is ready and fermented enough, so enough differentiation and magma is accumulated, so it's ready for the next caldera forming eruption. This is kind of the concept. And since Santorini has had this last caldera forming eruption rather recently, we think it is in this stage, which means frequent eruptions, but of lesser magnitude. Where is Santorini located? So Santorini sits on the South Aegean volcanic arc, produced by the subduction of the African underneath the Eurasian plate. And if we have a look at the profile across the entire Aegean region, we see that this is a topographic profile here we have Crete here, Santorini over here. And then these are the depths of earthquakes, which kind of image the slab. So at a depth of about 120 kilometers, this is where the partial melting occurs that then feeds this multi-storage magma system of Santorini. And this is why we have volcanism here. The volcanic history of Santorini itself is pretty well studied because since it had a caldera forming eruption, the cliffs of the volcano are pretty well exposed. So this is an aerial image of Santorini. You can see the caldera has this largest island here, smaller island Terracira over here. This is part of the older complex. And then in the middle, we have the two new volcanoes. So these are part of the Kamini volcano. The larger island is called Nea Kamini. The smaller one is Palea Kamini, which means old and new burnt islands. And this is, just move this over here. So this is kind of a photo I took from the caldera cliffs. And you can see that it is what we would assume is kind of a layer cake. So the different eruptions of Santorini are exposed here on the caldera cliffs. And if we want to study them, you can basically sample along the cliffs. It's not that easy, for sure not, but people have been looking at this for a long time. Thanks to the work of, for example, Tim Druitt and others, we have a very good idea about Santorini's eruptive history for the last 250,000 years. There were older volcanoes that date back down to 650,000 years. But what we see is that typically we have a large explosive eruption, which is in yellow indicated, and then we have a shield forming phase. So a new volcano, it's more effusive volcanism forms afterwards. And now we are here. So after the Minoan eruption, the next shield building phase is the Kamini volcano. So once again, to reiterate this, we are now in this rejuvenating stage. And this is an aerial view of how Santorini looks like. We can see the two islands that emerged after the Minoan eruption, and then some submarine lava flows that extend here into the bathymetry. The last eruption of Santorini occurred, so this is actually an historical eruption from 1688. Some of these eruptions were pretty nice to see. That's at least what historical accounts tell us. So typically these were effusive eruptions. There were some smaller ash plumes, but you can see people were getting pretty close by, as you see by the ships. So in general, the hazard potential of these eruptions is considerably lower if we compare it to large-scale explosive eruptions. And as I said before, so the last eruption occurred in 1950, and you can see it over here. It was a quite small-scale eruption. And due to the good historical accounts, we know the history of Santorini pretty well. And what you see here in the semi-transparent colors, these are different eruptions that are related to historic times. So the first time an island emerged that has stayed over the sea surface is when in 46, 47 CE, the island of Palia Kameni emerged. There was a smaller lava flow in 726. And then after a break, since 1570, the island of Nea Kameni formed with different islands that at some point merged. And as I said before, most of them are pretty well described. There has been work by, for example, Elvinomiku from Santorini that has traced some of these lava flows into the submarine domain. This is indicated by these dashed lines. But there's one event that stands out in all of this, because we have the historical account, and in the early summer of 726, the sea was seen to boil. Large blocks of pumice were ejected in such quantities they covered the sea over an immense area. Wind carried them to the coasts of Asia Minor and Macedonia. This is a pretty considerable event because the distances that are described here cover the entire Mediterranean or the entire Aegean Sea. So this is where pumice from these eruptions have been noticed, and it's related to Santorini. But so this was in historic times. This is what ChatGPT thinks this eruption might have looked like. But the question is, where are the deposits of this eruption? Because in 726 on shore, we only have this small lava flow. There are small pumice fragments on Palia Kameni, but in a centimeter scale. So nothing that really fits this description. So we have a conundrum here. What happened? Have the historians mistaken Santorini for a different volcano? Was this over-exaggerated? Where are the deposits of this eruption? To answer this, IDP Expedition 398 came to the rescue and drilled inside the caldera of Santorini. So we have 4 drill sites within the caldera, 2 in the northern, 2 in the southern basin. And for me being a marine geophysicist, I look at this based on a seismic line, which you can see here in white. And this is what we're going to look at the next slide. So this is a seismic line coming here from the southwestern breach, crossing the flank of Kameni and entering through the northern breach over here. And we have looked at this data for a long time. We established a stratigraphy. So these horizons indicate different units that we correlate to each other. And our aim was to drill down to the acoustic basement, so below this brown horizon, to also get some records of the Minoan caldera collapse deposits. But this is what we got. So we have one drill site, 1595, that went a little bit deeper. The other drill sites only penetrated the upper 2 units. Why? Because volcanic deposits are extremely hard to drill. We broke the record of getting stuck with a drill pipe because the holes collapsed on us, and we didn't want to risk anything in the caldera. So whenever things got critical, we pulled out. But if you get stuck, you have to use explosives to settle the pipe. That's why we didn't want to do it in the caldera. But from this, we get a good idea about at least the history of the Kameni volcano. And this is again a map, and we drilled 5 lithological units indicated by L1 and L5. I have to say that in all drill sites, we recovered unit L1 and L2. The others were only recovered at 1 drill site, so not as reliable probably. But it is very interesting to say that this uppermost unit, L1, consists of different ash deposits. It's pretty chaotic in a way. And then this unit L2 consists of basically ash and pure pumice. And we can relate this to one eruption. This has been deposited during one eruption. And some of these pumice fragments are also pretty large. So this is the lithology. So we can correlate our seismic units, which we call S1 to S3, to our lithologic units. And the most important part is we can correlate one seismic unit with this lithological unit, our pumice unit, throughout the caldera. And this is how this core seismic integration looks like. We have kind of this ash unit, which is more or less semi-transparent. Then we have the stratified unit L2, which corresponds to this big eruption depositing ash and pumice. Now the question is, okay, we found a big explosive eruption. It has a thickness of like 40 to 50 meters at least where we drilled it, but what is the age? It's not easy to date these eruptions in a caldera like this, so we employed this kind of 3D view where we look inside the Kameni edifice, and we can relate lava flows from onshore to our seismic stratigraphy. And the most important point is that this unit S2, which corresponds to this pumice unit, is underlined by the Palia Kameni eruption, 4647, but overlined by the 726 eruption. So it means we have a rather good idea of when it happened. And this time, people have been living on Santorini. There are no reports of a big eruption in that time, except for the 726 eruption, which gives us good confidence to say, actually, we found the deposits of this big eruption, and we can come up with a timeline. So after the known eruption, we had the early submarine stages. There's some not very well constrained records of volcanism in the caldera. And then here, this kind of thick unit accumulated in one event. And then Nea Kameni has evolved mostly sub-area, which gave us this unit S1 over here. We also did some geochemical fingerprinting. So we know the element ratios of eruptions from Santorini and the Aegean pretty well. And I just want to point you towards the Kameni field here in red. And we did these analyses, and we could show that, yeah, what we drilled has a Kameni signature, and it also corresponds to a unit that we found outside of the caldera in a gravity core, which also indicates that there was an ash plume related to this eruption. So using a very dense grid of seismic data that we have, we can map out our different seismic units, S1, S2, and S3. And whereas, for example, S1 is kind of deposited in the sinks of the caldera, we can see that our unit S3 is really thickening towards the volcano. And this is where we think the vent has been situated. So it's thickening towards the vent, reaching a thickness of about 250 meters, pretty significant. Using the physical properties we measured on board, we can come up with all kinds of parameters for these deposits, which allows us also to convert the bulk volume of this eruption to a dense rock equivalent. So this is if we remove the Kameni edifice, we see a nice cone over here. When we come up with a volume of approximately 0.5 cubic kilometers dense. And then if we add a distal ash layer, the entire unit has a thickness of 3.7 cubic kilometers bulk in this case. And this is excluding all the reported pumice. So it's a pretty big eruption, not as big as, for sure, not as big by magnitude as the Minoan eruption, but it's pretty significant because we were thinking that Santorini at this point is not capable of producing these eruptions. Implications of this is, for example, the hazard assessment. So previously we were looking at, like worst case eruption scenarios, and such a big eruption has not been considered so far because we didn't know it existed. And then also our study shows that the lava flows of the Nea Kameni sit on top of the pumice cone from the 726 eruption. It's not the stablest foundation of such an eruption because this is how the stuff looks like that we drilled. And from, for example, Anak Krakatau in Indonesia, we know that within calderas and a new edifice, they can collapse if you have a proper décollement surface. And we think this could be a reason, or it could be something to consider at least. Not saying this is anywhere near imminent, but this is a scenario that we need to consider. To finish off this presentation, just the implications of this eruption. So it is known that the occurrence of floating rocks at the sea surface prompted the emperor of the Byzantine Empire at that time, in 726 to think this is a sign of the gods. And he imposed the iconoclasm and banned the showcase of religious symbols, leading to all kinds of economic problems and social problems. So this is the extent of the Byzantine Empire before the eruption. This is after the eruption. So of course, it's only related to this event. No, but it just shows that eruptions in such densely populated areas, even in that time, have implications. So the conclusion is Santorini is capable of producing large explosive eruptions. A sector collapse is a serious but previously overlooked scenario. Rejuvenating calderas like Santorini might be more hazardous than we thought. And my favorite conclusion from this is we are really blind to the history of these shallow marine explosive eruptions. Because if we miss this eruption in Santorini, which is so well studied, we for sure have missed so many other events at other volcanoes, which are not as well studied. Okay, with this, if you want to look up, this paper was published last year. And yeah, thank you very much for your attention, and I'm happy to answer some questions.